The best practices for using redundancy patterns depend on your particular system. You should make sure to consider both your hardware and software redundancy needs. While not emphasized in these patterns, a doer-checker approach does provide some diversity since the doer and the checker are different software. However, relying upon that for safety is tricky because even somewhat different software can have similar failure modes. In creating your redundancy architecture, you should use building blocks as appropriate to achieve your particular needs. Some of the building blocks we saw were using failover to improve availability, using a 2 of 2 pattern for same-SIL fault detection, and using a doer-checker pair for mixed-SIL fault isolation and fault detection. The pitfalls for these patterns are, first, don't double spend your redundancy. It's important not to take credit for the same redundancy in 2 different ways, such as availability and fault detection from the same pair of redundant components. Generally, clever shortcuts don't work. So if you see a pattern that looks too good to be true, make sure you draw circles around all the redundancy and make sure you're not double counting redundancy. Generally speaking, if it's a really clever shortcut, it's probably not safe. Make sure you avoid single points of failure. Another aspect that's inherent in these diagrams is that you need to have sufficient I/O redundancy. If you have a single sensor or a single actuator, no amount of computational redundancy will help you if that sensor or actuator fails in a critical way. Finally, the acceptable safety patterns depend upon your safety argument. You and you alone are responsible for your system safety. These patterns are meant to help you, but ultimately you have to use them in the right way and make sure that they match up with a reasonable safety argument for your system.